Hey everyone, in this video I want to talk about borrowing in fractions. Borrowing is no different than when we borrow in basically whole numbers and decimals. The reason that we're doing that, we're literally going and getting some more number to boost another number so that we can subtract from it. The whole idea of borrowing is the top number is usually smaller than the bottom. Well, in fractions, the number that we're subtracting is the numerator. Remember, in adding and subtracting, your denominator has to be a common denominator. So the subtraction part comes on the numerator side. So once you start working with a problem and you find out in subtraction that the top number is not high enough, you're faced with a dilemma of trying to boost that fraction higher. Now, there's a couple different methods. The one that I really prefer that you learn is to understand borrowing with fractions, because this really tells me a lot about your skill level in fractions. So let's get started. This particular page comes with it within your packet. The second packet is called Subtraction of Fractions with Borrowing. There's two examples. Example 1 is 7 minus 1 1/3. That's 7 as a whole number minus 1 1/3 as a mixed number. That situation is a little different because it has a whole number, and I'll tackle that next. But first I want to do example number 2. Example number 2 is 5 1/3 minus 2 5/6. These are two mixed numbers. Whenever you have to borrow, you have to have mixed numbers, at least one on top, because you have to have something to borrow from. So that's kind of a key. But let's go to our next page and let's write that out. So it's 5 1/3 minus 2 5/6. So it's subtraction, so we need a common denominator. And if I look, I have a 3 and I have a 6, and they are not common. So the first thing I want to do is ask myself, does the smaller number divide evenly into the higher number? So the question is, does 3 divide into 6 evenly? Because if that happens, you can use the highest denominator as your common denominator, and that works. 3 divides into 6 evenly. That means we can use 6, and we like that because that means this bottom fraction, to the 5/6, is already in 6th. And then I only have to do the top one. And in order to make 1/3 an equivalent fraction with 6 in the denominator, I have to ask myself, 3 times what would give me 6? That would be 2. And so I have to multiply the top as well by the same number. So 3 times 2 is 6, 1 times 2 is 2. I now have two new equivalent fractions with 6 in the denominator. Let me rewrite that. These two get a little messy. And right now I have 5 2 6 subtracted from 2 5/6. So this is gone. Now, yes, I have a common denominator, but I can't subtract 5 from 2. 2 is smaller than 5. And that's where borrowing comes in, just like we do in regular subtraction. Well, what I'm going to borrow from is this wonderful little 5 over here. I'm going to borrow 1. So if I take 1 away from 5, this whole would become 4. Now, because I'm in 6th, what I want to do is I'm borrowing 1 whole in 6th. And remember, 1 in fractions can be written with anything with the numerator and the denominator the same. For instance, let me get another color here. 4 over 4 is equal to 1. 2 over 2 equals 1. 10 over 10 is equal to 1. When you work with fractions, that's a really good thing because I'm in sixth and I want to boost this fraction up by borrowing 1. I want to borrow it in sixth. So I will write 6 over 6 because that equals 1. And that is what I borrowed from my 5. What I'm essentially doing is boosting this top fraction up. We have a common denominator of 6, so I'm going to add the numerator. 6 plus 2 is 8. And then I'm going to rewrite this again because it just keeps getting messier and messier. So my top number is now 4 and 8 6 minus 2 and 5 6. So I'm subtracting. I have 6 as my common denominator, and I'm good to go because the top number is now higher. So first I'll subtract my whole numbers. 2 from 4 is 2. I have 6 as a common denominator. 5 from 8 is 3. And we all know that this is not in lowest terms because 3 is half the denominator. So that makes that automatically 1/2. So the answer is 2 and 1/2. And you're done. It's as simple as that. Whenever you're borrowing to boost up a top fraction so that you can subtract the bottom number, you're always borrowing 1. And we can write 1 in any denomination that we want to. In my case right now, we're in sixth. So I could write 1 as 6 over 6, boosting that top fraction up, and that allowed me to make the full subtraction. Now, let's talk about what happens when you have a whole number. For instance, the example that's given is 7 minus 1 and 1/3. There's a couple things that you can do. One is, let me write this vertically, 7 minus 1 and 1/3. 1 over 3. What I can do is the same thing that I just did in the last problem. Obviously at this point, I can't subtract 1/3 from nothing. There's nothing above it. So I would borrow 1. Let me change color. So if I borrow 1, the 7 will become 6. And now I'm in thirds, so I want to actually put my 1 in thirds so I keep a common denominator. And that's 3 over 3. So this problem is now 6 and 3 over 3 minus 1 and 1/3. When you do that, you borrowed 1, you made it 3 over 3 because you're in thirds. Everything is good. You can subtract now because you have a common denominator. The numerator on top is higher, and we're good to go. So 1 from 6 is 5. You have a common denominator of 3. 1 from 3 is 2, and we know that is in lowest terms because that's my favorite. The 2 is 1 less than the denominator, so you know you're automatically in lowest terms. Another way for converting or using a whole number is a little bit more tricky, but it's not something that you can't do. It's not that difficult. 7 minus 1 and 1/3. What we can do is we can actually convert everything to an improper fraction. How do I convert this whole number to an improper fraction? Let me erase this a little bit. Well, let's write 7 as 7 over 1 because that's what a whole number is in fractions, 7 over 1. Actually, let me move that over and put that here as 7 over 1. Okay, so as you can see, a couple things are wrong right now. One is I don't have a common denominator. I have 1 and I have 3. But I also have this whole number down here, and I have nothing up here to subtract it from. So I have all kinds of things going wrong. But the way to fix this is to change everything to an improper fraction. And right now, I want to make my common denominator 3. Whenever you have one and another number, it's the highest number that's going to be your common denominator. Another way to think about this is, remember method number 2 is you can always take the two numbers and multiply them together, and that will always give you a legal common denominator. So 3 times 1 is 3. So we can move this over and we can convert 7 over 1. 1 times 3 is 3, and 7 times 3 is 21. Now, I still have 1 and 1, 3. So the problem is, at this point, I still don't have anything above the 1, but this 1 has not been converted to an improper. So let's rewrite that as an improper fraction. 21 over 3 will be on top. Remember, 3 times 1 is 3, plus 1 is 4. And we'll write that 4 over 3. So now I have 2 improper fractions. I have 3 as my common denominator, and the top number is bigger than the bottom. So basically, I'm good to go. Let me get a new page here and rewrite that so I have some room. 21 over 3 minus 4 over 3. So basically what I did was I took the original problem of 7 minus 1 and 1/3. I made both of these fractions an improper fraction. This one here is pretty easy. We know how to do that. 3 times 1 is 3, plus 1 is 4 over 3. The 7 over 1 was a bit more complicated, but certainly doable, by asking myself, 1 times 3 is 3, and 7 times 3 makes 21. So now I have both numbers as an improper fraction. Now let me go back to the problem. 3 is our common denominator, and 4 from 21 is 17. Remember, just like we talked about, mixed fractions in multiplication and division must be converted before you multiply or divide. And with division, of course, you have to flip the second fraction and it becomes multiplication. Changing mixed numbers in addition and subtraction is not mandatory. But some people prefer not to borrow, and so they will change all their fractions to improper. In almost all cases, you will end up with the top number that is higher to subtract. But, as in multiplication and division, you also end up with improper fractions, and they have to come out of that. You don't want to leave your answer as an improper fraction. So let me give myself a little room here. What you have to do is take that 17 over 3, make your fraction house, and divide out. 3 goes into 17. How many times without going over? Well, 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. That's too much. So 3 times 5 would be 15, and I'll subtract 15 from 17, and I get 2. And I'm basically done by writing this as a fraction 2 over the divisor, 2/3. So 17 over 3 is actually equal to 5 and 2/3. And we did that earlier when we did borrowing, so we know that is correct. Okay, so I gave you a couple different ways of borrowing in subtraction. If you find that your top number is not big enough, you can't figure that out though in subtraction until you've gone through the process of finding your common denominator. So once you have a common denominator and you see that your top fraction is too small, then you basically can make the decision. Do you want to convert everything to improper fractions, or do you want to do that fun little method of borrowing 1 and boosting your top fraction up. The choice is yours. Both ways are fine, and they will get you the answer that you need. I hope this helps. I'll see you in class.